Okie doke. So by semi-popular request on Twitter, I've got this second copy of this bad boy. I'm going to take it apart and just sort of give you my thoughts. What is it? It's supposed to be solar powered, as you can tell. Hello, this is I. Solar powered cat repellent. So when you turn it on here, a wee light comes on every time it senses a movement. I'm not going to pretend to be steady for long enough for it to extinguish itself, but you have to believe me when I say that it's extinguished now. If I turn it, hey, it's extinguished. And now if I move in front of it, hello, McFly. There you go. Anyway, whatever the light does, it does. It's supposed to produce sort of, high-pitched noise that allegedly irritates animals such as cats. And we've got a bit of a pooping problem. And instead of sending my videos of the neighbors' cats to the neighbors, showing them how their pupils are defecating in our gardens, I thought I'll just I'll order 2 of these and install them in our garden instead. So this is going to be a little teardown because I'm curious what's inside. I already took one apart. There have been some pictures online, but I thought I'll do it again, and I'll do it on the video. Oops, my hand appears to be massive. Apologies for that. 1 moment, please. Let's see if this looks any better. Anyway, I'll spare you the screw operation. Okay, all the screws are off, and my first thoughts, actually, before I carry on with the actual teardown, I don't know if you can tell, but the size of the solar panel compared to like other trinkets, such as your USB lights, USB solar lights for a garden, or even a little screwdriver. This is huge. Here's a standard size LED for a size comparison. It's massive. It's absolutely massive solar panel, and I think it's entirely covered in glass. At least it has a bit of a sharp edge, so I'll be careful with kids and stuff. This is obviously made in China, so safety has not been the biggest priority when they were making it. At least not by our Western standards. Anyway, I'll turn it around because I suspect this button's going to fall out as soon as I do this. Hey, I was right. So it's a nice casing. This is obviously, there's a room for the battery in here. It's kind of nicely done. The solar panels are just gunked up, so the water from the outside does not get in, at least that way. That's nice. This is some sort of a glue that looks a bit funny. Don't know what sort of glue is it, but you can tell that it has a bit of a gunky thing to it. You may notice that this one is fake, so this is just basically done purely for symmetry, so it looks like like an owl. Oh, it's all falling apart because I told you the button's gonna fall off. It's upside down. All the electrons are just gonna go to Australia and hit Dave in the face for making such silly jokes. Anyway, the dome is huge, but you may notice that the sensor is actually tiny. What happens is basically each one of these little thingies is just a little lens that, if this was engineered properly, which I highly doubt, it would kind of sort of trying to focus the beam onto this area. In reality, it's just kind of like, how you're doing, basically, Chinese way. Nice thing is that they have connectors, at least for the speaker. They didn't bother for for the solar panel, but yeah. And a connector for the battery as well. Oh, that's nice. What do we have here? We've got, instead of just standard rechargeable batteries like some other ones do, this is actually nice-ish battery. Some other manufacturers, instead of having a double A's, just put this thing in there. I presume it's just 4 of these. So basically, this is this is 2. This is a third of a double A. You know, it's about a half of double A. So if you look at this reputable brand double A rechargeable, this is about, you know, if I put my finger in there and there, give or take, it's half of it. Which is funny because it says 2/3 double A. Or does that mean something else? I don't know. By the way, I'm not going to edit massively this video. This is just for people who've requested me looking into this in slightly more detail. Okay, so here's the battery. Like I said, there is just one speaker, and speaker is probably too much of a word. This is obviously going to be producing, you know, very high-pitched noises, sort of. Well, that didn't last very long. Never mind. I know how it sounds like. It doesn't sound like. So I can hear pretty high ranges, and some of these cat repellent ding dongs annoy me when I walk past them. I can actually hear them. It's like a very irritating sound. And no, I'm not a cat. Before you ask. I know for a fact that this does not produce such a low frequency. This is actually producing over 20 kilohertz, and I'll show you that in a minute. So I don't need a speaker actually to show you that. I just need a battery, cover the solar panels, pretend that there's a movement. Right, I'm not going to go full big Clive on you and actually tear down the board. But if you noticed, one of those chips has a very nice marking on it, and I think I'm holding it upside down again. I have a tendency to do that. Is this going to focus so close? Anyway, I'll flash the this is basically BIS or BI something, BI8001. Let me take a photo of it. Yeah, so it's BIS001. I'll let you look it up yourselves. And what do we have there? Sadly, it looks like they've decided to rub off the other one's details. Which, why would you do that? Because, you know, in China, every second house has a little factory of trinkets, and you don't want your neighbor essentially to start manufacturing what you've been manufacturing for, to, you know, have a penny less and sell it off to your supplier. That would be my wild guess. Where do I have a wee torch thingy? Ah, let's use a second phone for that purpose. There are way too many phones around here. As an iOS developer and Mac developer, I've got way too many sort of Apple devices around. So now that we have a second torch, we can actually see things better again. This is upside down. Hopefully you can see the BIS001 better. And the second chip, as you can tell, the U2, has been rubbed off. I don't know why would you do that again. So the quick analysis. What do we have? Some, which is the solar panel basically input. comes into this panel. It's very nicely marked, this this board. We've got a choke, a diode, and it's the switch that just turns it on and off. What does the switch do? It turns something on and off. Again, I'm not going to go into details on this, but the I know for a fact that the little chip in here is for the IR detector, the sensor thingy, and it potentially has the other functionalities, but I don't think it's used for anything else. And the microcontroller, which I presume this is it. You know, a little 8-pin microcontroller is just driving the speaker and kind of doing the actual, you know, hard work. Anyway, the moment that everybody was hoping for is going to be me. Let me plug in the battery back. I presume it doesn't need hello, McFly. Oh, I need to turn it on probably, don't I? Yeah, that usually helps. Power usually helps. I'm trying to hook up oscilloscope to it, and I've just noticed the minus is coming to the middle of it, but that goes all the way around. So if I just hook it up to this little fella, that should allow us to probe things. Oops. Let me do this properly again. And because this is 4.8 volts, actually pretty decent. Let me turn it down. This is the actual probe. Oops, apologies, sorry about this. Where's the speaker? So the speaker comes out of this, comes around to the battery plus. So on one hand, speakers at all times attached, you know, via this little fella, and the other leg of it goes to this little choke, or coil of some sorts. Let me just do this. You can see, or you can't see because I need to raise you up for you to see the oscilloscope screen. That's my little riggle. So if I hook up the other speaker output, here we go. And let me attach this and the trigger point a little bit. Ooh, there's lots of strange things happening. What is that? Is my triggering going funny? Let me just put it in auto. Oh, guess what? This isn't going to work very well without load. One moment, please. So the funny thing is, I don't need the channel 2. As soon as it detects the probe, it just wants to. Let me center that again. Yeah, whatever. 8 volts. Why is it in? Anyway, you can tell that it behaves kind of funny, and it's because there is no load. As soon as I plug the speaker in. Actually, can I do this? I want to. So as soon as I do this, I don't know if you can see what I'm doing. Watch the screen. I mean, apologies for this, just a trigger. But all of a sudden, with the load plugged in, it's all good. And I don't know if you can tell. Let me zoom you in a wee bit to the screen. But this is hardware frequency. I can't make the font any bigger, but it's 52, 56, 62, 56, 49, 57. It basically goes 44, 47. It changes every so often. Let me bring you in a little bit closer so you can see what's going on. But this is now producing the sound essentially, and what is our peak to peak? Let's turn the measure on. So No way, peak to peak. What? 30 volts, 21 volts. That's a bit much. I don't want to fiddle with the oscilloscope whilst I'm recording because this will go badly, trust me. But anyway, the frequency seems to be pretty high. It basically goes, actually, the frequency showing at the bottom there, I think is the better one. So it's 44 now, 52, 61. It'll go back down now, 24. And it's just going to keep on doing that because I'm moving around and kind of triggering it. So that's our little circuit. I hope I didn't burn anything by, presumably there's a little transistor in there at the bottom. You can't see now that I'm kind of, let me just pan you a little bit down. There you go. There's a little transistor in there, and I think, although I don't know, again, maybe that transistor actually is driving the speaker. I don't know. I really don't want to have to dissect this circuit, but you can see it's actually quite complex for what it's doing. You would have assumed that detecting the movement would just be a matter of having a transistor or two, and then having a microcontroller, having that as an input, then deciding what to do, and driving the actual speaker. These microcontrollers quite often cost just like 5 to 10 cents or pence. So it's quite surprising the amount of circuitry that comes out of China, and not only in China, that actually has everything done via a little microcontroller. Like I had a soap dispenser about 5 or 6 years ago that I took apart because I was curious, obviously, as you do. And the circuit, and literally just had a microcontroller dispensing soap. So, one of those things where you just wave your hand and it just gives you a little blob of soap. It obviously made more sense economically for them to do it that way. Let's have a look at the LED. Is the LED just steady? Yeah, LED is just steady. So the LED doesn't blink. What about the sensor? I actually know virtually nothing about the these sensors, so I might need to have a look at that. The solar is not going to produce anything at the moment, obviously. But anyway, that's the circuitry in a nutshell. Let's just take the probe off. So, in conclusion, before I put this together, I haven't actually tested it on the real cat. Like, if I wish I had a neighbor who was willing to be like, oh yeah, your cat's pooping in my garden. Let me see whether the cat actually reacts to this. This doesn't have to be. There has no be. It's not cruel. You just put it in a room or outside and see how the animal's going to react to it. Whether it's going to come by or whether it's actually going to be upset about it. And then if you see them upset, you just remove it and you know it worked. So no harm done really. Anyway, you'd be surprised how many things upset animals that you have no idea on a daily basis if you have a cat or a dog, and you don't even notice. Anyway, I like this, the fact that the battery is kind of sealed nicely and in one kind of box. The fact that everything is socketed, or everything apart from the solar panels, then they wouldn't really expect you to take this apart. The bummer number one is the glue. Blame me. The other one that I have doesn't have as much glue. But yeah, the fact that the wire just came off. This is a bit how you're doing. Okay, look, I think I have managed to do this properly. I blew my I blew the what do you call it? A fuse in my milliamp range, but if I plug it in and the LED is now on, this uses about 130 milliamps and then drops down. It's kind of all over the shop. And now it's 0. I mean, it uses microamps basically when it's just on. So, given that this is it's not supposed to be on all the time, and obviously your cats and dogs are not going to be running around, all the time in front of it. 300 milliamp hours. So this will probably last, what, about 3-4 hours if you're fully on. That answers why the battery pack is so, or the rechargeables are so big, I suppose. Again, I have no idea why the circuit's so complicated. Why there's only one speaker? Like, well, I suppose money is the answer, but surely having 2 speakers running at lower frequency or lower amplitude would be at the same time would give you the same output. Or am I just too naive on this front? I don't know. But yeah, the complexity of the circuitry is baffling. But the biggest thing is, like I said, the fact that it's not. This isn't designed for outdoors really, like, especially if you lived in a very warm climate. This would the humidity in the morning would ruin this even quicker. I suppose for Britain it might be alright, but as a society, in Britain we throw out so many solar trinkets every year because they just rust, and I fixed them myself, and I kind of reconditioned them for my own use. And in fact, I'm thinking about designing a product that will kind of be a better solar light. However, if it was made in the UK, which it would have to be, I don't see myself selling it for anything less than £10 a light, and I don't know how much people would be willing to pay for these things. But that's the society we live in. That's a subject for a different rant. But there you go. The little trinket in there. Actually, before I go, let me just find something else. Yeah, just as I thought. Sorry about this interruption. Oh, hello. Again, soldering job on this is probably not the greatest. I'm not going to zoom in just to show you, but I just sheared this one off, and this is a bit how you're doing as well. Kind of just weaving in the air, I suppose this is just going to be put in, but I don't know. This is this has been sent all the way from China, so it's been presumably flapping a little bit in the ether internally. Anyway, and obviously this is ended up this way. So I just looked up the data sheet for this BIS S0001 chip, and it's a PIR, which is the passive infrared thing, which is what this is. It's essentially like a little sensor that senses movement. It's a controller for that sensor. Again, but I'm pretty sure I've seen circuits in the past where they've employed one of these sensors, and there was just 1 or 2 transistors actually manning it. And surely, if this is a microcontroller, you don't need another massive chip. But this looks like it was actually from purely design point of view, like commenting on kind of Chinese designs. this one actually everything is nicely silk screened. You know, you can tell that there is a second LED in there, which I actually have never seen lighting. And presumably, if I gave some oomph to the, let's actually try that. My pure guess is going to be that the solar panel is going to output about, I don't know, 3 volts, 4 volts. Oh, no, actually, apologies. It will give you more than that. But let's just naively assume that it won't, and see if there's an LED that actually lights up. So doing it on a camera is a bit of a liability. So if anything goes wrong, it's my fault. So this is a negative. It helps when you turn on the output. I've put my power supply to about 3.3 volts. Yay! There's a little LED there. That uses about, I don't know why it's flickering. That's about 20 milliamps, which it's probably unhappy because I've not plugged in the battery. But there you go. I just basically, just so you can tell what I've been doing, I've just plugged it into my little power supply there. Which I'm going to turn off now because we don't want any surprises. But there you go. That's this little trinket. I'm going to have to solder now another wire. Let me know if you have any questions, and if you want me to do any electronics on this channel. I mean, historically, all my electronics videos were actually the most popular, shockingly. So, anyway, adios, auf Wiedersehen, goodbye, and so on. Thanks for watching.